your second video for the notes for 1-3 piecewise functions. And this picks up where we are actually going to write the equation that matches up with the graph that's given. I am going to scroll just a tiny bit so you can see the bottom of the instructions over here. So first thing you want to do is identify how many pieces you have. In this particular equation, we have 3 different pieces, and I'm going to number them. So I have piece 1, and also color code so we can keep them straight. Piece 2, and then I'll call this one piece 3. So if your pieces are horizontal, like we have up at the top here, you are going to name the height at which they occur. Piece 2 and piece 3 are horizontal, so whenever I write the equations for those pieces, I am merely going to name the y height that they occur at. If you have a diagonal piece, like piece 1, we're going to be writing the mx plus b form of that, which means we need to find the slope and we need to find the y-intercept. And I am going to start with piece 1. So we're down here in this mx plus b. So for piece 1, I can pick any 2 points on the line and count the slope. So I'm going to be going down 1 and over 1, which means my slope for piece 1 is going to be a -1. Now, for the y-intercept, piece 1 does not actually cross the y-axis. But if we extended it and see where it would cross the y-axis, that's what you're going to use for your y-intercept, for that b value. So I have my ruler here. You can use any straight edge if you want to get something that's close there. So you can see if I'm extending this line, you can see I'm coming down here and drawing that. If I extend that line, I would be crossing down here at -2. So my y-intercept for that is actually going to be -2, which means my equation, I plug in the m, plug in the b, I have a -1x, and apparently things are going to go weird now. See if we can get this to calm down some. So I have a -1x minus 2 as the function there. Now after the comma, we are going to figure out where the boundary is. So my boundary line, I'm going to use something bright here, maybe like a yellow. My boundary line occurs right here. And that is at the x value of -3. The line exists to the left of that -3, and that dot is closed, which means my boundary is going to be x would be less than or equal to -3. So identify the x value of the boundary and then determine whether you are less than, in between, or greater than. So that's piece 1. Piece 2 is horizontal, a lot less work for that. We just name the height. So if we come down here, we can see my height, there's -1, -2, -3, -4 is the height that we are at. So that is going to be the equation part. Now we have to figure out the boundaries. Well, you can see here I drew in this one boundary at -3. We have another boundary over here at +3. So your x would have to be in between +3 and -3. On the -3, there is an open dot, so that inequality is not going to have a line underneath it. But over here at +3, that's a closed dot, which means it would have the line. So your boundary for this middle green piece is going to be -3 is less than x, which is less than or equal to a +3. Now we're on to piece 3. Piece 3 is also horizontal. It is at a height of -3. Again, you're naming the y value. Whenever I say name the height, that's the y value. This one exists on the boundary of +3, and it's going to the right, which is the greater than side. The dot is open, which means there's going to be no line under the inequality. So it's -3 for the x's that are greater than 3. And that's how you write the equation. Most of the equation stuff that you guys are going to be doing is going to be simpler than this. Being that this is 3 different parts, this is going to be one of the more complicated ones that you'll see. But if this seems pretty easy to you, you should breeze through the next part. So here's our next one. Again, we got to look and see how many pieces we have. So I have one piece here, and I have a second piece here. Determine whether the pieces are horizontal or vertical. Well, piece number 1 is a horizontal piece, so I would name the height, and I can see there the height that that one is at is -3. My boundary this time is at -2. Piece number 1 exists to the left of that -2, so that's less than. And the dot for that horizontal piece is open, so there would be no line underneath the inequality. Piece number 2 is diagonal, so I have to name the slope and the y-intercept. So the slope of this one, I need to pick 2 points. I can do these two. This is a down 1 over 1 again, which means my slope is going to be -1. -1 over 1 is -1. And this one actually does cross the y-axis. So the b value here is going to be -1 as well. So that would be the equation -1x minus 1. And again, you don't have to put the -1 in front of the x. I've just done that for consistency's sake. You can just make that -x minus 1. Again, you don't need to put the 1 there in front of the x. And now we need to look at the boundary. This piece exists to the right of the boundary. The dot is closed. So that's going to be if x is greater than or equal to -2. Again, remember, you shouldn't have 2 closed dots above each other. One should be open. So whichever one is the closed dot, that's the one that gets the line under the inequality. And that's writing a piecewise function. This is something that we will practice next week, well, or later on this same week, depending on when you're watching this video. But please go back and rewatch those if you're not quite sure how to do those. We are going to look at something a little bit different, for example 6, that is kind of similar to what was in the last video. Because this one is graphing, this is actually going to be a step function. So we have a table that gives us the shipping cost of items that are purchased from some online store that's dependent on the weight of the items. So there are places where how much you pay for shipping is going to depend on how much your total package weighs. Typically, though, you're going to be paying a shipping cost based on how much you spend, but if you are purchasing from some vendors, they do base the shipping based on the weight. And that's what we have here in this table. So 0 to 2 pounds is going to be a $5 shipping cost. Notice that there is a line under the inequality with the 2. 2 to 4 pounds is $8. Notice 2 does not have a line under it, 4 does have the line. 4 to 6 pounds is $11. 6 has a line under it, 4 does not. 6 to 8 pounds is $14. 6 does not have the line, 8 does. Which means every single one of these, you're going to be going from an open dot to a closed dot. So open to close, open to close, open to close. So whenever we're graphing these are just numbers. So if you were looking at these set up like a piecewise function, these would be different y heights. So they are going to be little floating horizontal pieces. But every single one of them is going to go from an open dot to a closed dot. And then it does ask us a few other questions. What's the domain and range, and what are the maximum and minimum values of the function? I am going to extend this just a tiny bit so that we can see everything that we have here. So I know you can see my table, and I'll scroll back up so you can see the other things that are there. On my y-axis, this is going to be my shipping cost. On the x-axis, this is going to be the weight in pounds of the item. And you can see I am counting by ones on the x and on the y. So whenever I scroll down here, just know that even if you can't see the numbers here, I am still counting by ones whenever I go through that. So the first one, you're going to be paying $5 from 0 to 2 pounds. 0 does not have a line, 2 does have a line. So I'm looking in between my x of 0 and 2, and then I'm going to be at a height of 5. So I have open circle to closed dot, 0 to 5, or 0 to 2, all at a height of 5. When I look at the next one, 2 to 4, I'm going to be at $8. So 2 to 4, I'm up at $8. Again, I'm going from an open circle to a closed dot. So you can see it looks like we're jumping from one step to the next. The next one, 4 to 6 pounds, we are going to be at a height of 11. So open circle to closed dot. And then the last unit, or the last entry in the table, 6 to 8 pounds, $14. That will be my last one. So this is a step function. It's a step function because we have these floating stair steps. You're jumping from one horizontal line to the next whenever you move up in your shipping. So now we're going to list the domain and the range. The domain is the list of all of the x values. Well, my x's go from 0 to 8, and the only thing that's not included is actually the value of 0. Even though I have these jumps, at the jump there is still a closed dot, so that's included as part of the domain. So my domain would be from 0 to 8. 8 gets a bracket because it's included. 0 does not get a bracket because it's not included. Now the range. The range, if you recall, is the list of y values. Well, we cannot say that our range is from 5 to 14. Because if we said our range was from 5 to 14, that would be like saying there's some time when you're going to be paying $6 shipping, some time when you're going to be paying $7 shipping, and 9 and 10. And we don't actually have weights that correspond with those. So because my function is just this series of horizontal lines, I'm just going to list out the range numbers. And this is the only time you're allowed to do this. The only time you're allowed to list the range numbers like this is if there is no other possible y value that could be in this question. And that's what's happening in this situation. For the maximum and minimum values, you are naming the y's. Anytime they ask you about the maximum or minimum, you're naming a y value. The x would be the location, but the actual value for the maximum min is going to be the y. So the maximum y would be the maximum shipping cost, and according to this model, my maximum shipping cost would be $14. My minimum shipping cost would be $5. So there's all the additional information that they asked for in this problem. This is something that you would possibly see in the real world. Like I said earlier, if you're buying from an online vendor, typically they have different tiers of shipping costs depending on how much you purchase. In fact, most of them have, free shipping if you spend over, $50 or over $100, depending on the vendor. So again, this is something you could possibly encounter. This is just putting some more of the math behind it, like what we've been going over in class. So look this over, rewatch this video. Feel free to go back and watch the first video that I made, and contact me if you guys have any questions.